The Exam Boost series is a set of 6 short sessions with a focus on helping Edexcel teachers to help students show what they know and can do for this year's summer GCSE Science exams. In this session, we will be looking at command words, what they are, how students should respond to them, and some common mistakes. Command words are those words in exam questions which tell students what they are being asked to do. Typically, if you were to ask a group of students to identify the most important word in a question, a significant number of them will identify the word which refers to the topic of the question, waves, photosynthesis, reactivity, or something similar. This leads too many students to base their answer on something related to the topic, but not necessarily answer what the question is asking. The answer they write as a result might well contain correct science, but it cannot gain good marks because they have not answered the question which was asked. The mark scheme, on the basis of which the marks are awarded or not, is entirely based on an assessment of whether and to what extent the student has provided an answer to the question which was set, not did the student know something about this topic. The command word is central to this, and so the command word is the most important word in the question. Understanding fully what these command words mean is a vital tool for students in maximising their exam performance. The command word is almost always at or near the start of any sentence containing the question, and there's usually only a single command word per question. It is good practice for students tackling an exam paper to underline the command word before attempting to answer. It's a constant reminder of what they are being asked. The command words poster that's shown here on screen shows the exact meaning of each of the command words used in our exams, so there are no surprises in what students are being asked to do. Delegates can download this poster from the Edexcel website on the GCSE Science pages. Just as important as displaying the command words and their definitions is us as teachers constantly and consistently using the command words correctly in our own questioning in everyday science lessons, and challenging and correcting any answer which does not address the command word used in the question. This snapshot of the poster, with the definition of describe and explain expanded on this slide, highlights the difference between these two command words, which are a very common cause of students dropping marks. Crucially, an answer to an explain question will need the word because, or something that means because, in the answer. One way of teaching and embedding the difference between these two words is to ask students to answer questions to which they fully know the content of the answer, such as a question about how they travelled to school this morning, but ask them first to describe how they travelled to school and then to explain why they travelled to school in that way. They can also look at examples of past students' attempts to answer exam questions, identifying where students have given a describe answer and where they have given an explain answer. Once they fully appreciate the distinction between the two categories of question, they can move to answering past exam questions on science topics which use these two distinct command words. This is an exemplar question from the higher tier physics strand of Combined Science 2023 papers, which illustrates well the issue mentioned before, that of students struggling to answer a question set in a different context to that in which they learned the concept. Here, candidates are required to apply their learning in one context, refraction of light, to a different context that they've probably not studied, refraction of sound. However, it also clearly exemplifies an issue with explain questions. You can see that the question asks students to explain why the refraction of the sound wave is different from the refraction of the light wave. The question says, Figure 7 shows the difference in refraction of sound waves and light waves when these waves travel from air into water. Explain why the refraction of the sound wave is different from the refraction of the light wave in Figure 7. The examiner has commented, candidates were unlikely to have seen refraction of sound as it travels from air to water in the way shown in the diagrams. Nevertheless, they should be familiar with the refraction of light diagram and be able to apply their understanding of why refraction occurs to explain both situations presented. The most able candidates could describe how a decrease in velocity of light when it enters a more dense medium causes the ray to refract towards the normal, and to reason that the velocity of sound must change in the opposite way, i.e. increase, to cause refraction in the opposite direction, away from the normal. Many candidates unsuccessfully attempted to either apply their knowledge that the velocity of sound is less than the velocity of light, or that sound waves were longitudinal and light waves were transverse. Although both are true, they do not explain refraction. The second paragraph from the examiner's report there says how the most able candidates were able to describe how refraction was caused by a change in the velocity of the wave as it entered one medium from another. However, reading the last paragraph, we can see that many candidates failed to explain refraction and why it was different in the two situations pictured. The difficulty for candidates was partially in not understanding how to apply their learning from one area to a problem in another, but that was exacerbated by them failing, when the content became challenging, to distinguish between a description and an explanation. This student has made a good attempt at the question. Sound travels faster through more dense materials and environments. This is because sound is passed through oscillations, and therefore more dense materials with more molecules would mean sound travels faster. Light travels fastest in vacuums. This is because it does not collide with other particles. However, in water, light collides with many particles, therefore slowing down towards the normal. The answer is not perfect, but it does meet the criteria in the mark scheme for the full 3 marks, so 3 marks are awarded. You can see the examiner comment. This response gives a good explanation in terms of sound speeding up as it enters water and light slowing down as it enters water. A selection of the command words are simply arranged in alphabetical order on this slide. Calculate, comment on, compare, describe, devise, evaluate, explain, give or state, justify. Although the distinction is not absolute, there is a definite range within the command words from those which are generally used in questions which require lower order thinking skills from students to those which require higher order thinking skills in order to answer them fully. In order to achieve higher grades at GCSE and beyond, students need to be able to tackle questions which require higher order thinking skills, as well as those of lower demand. Looking at the command words used in Pearson Edexcel Science exams, we could say, for example, that command words such as state and describe would fit fairly neatly on the hierarchy shown on this slide into the remembering end of the scale, whilst command words such as evaluate and devise would be close to the terms at the higher level thinking end of our hierarchy. When developing the competence and confidence of our students to answer questions of all types in order to maximize their performance, it will be necessary for students to regularly ask higher order questions as well as lower order ones. One way of ensuring this happens on a regular basis is to include questions within our lesson planning. For example, when setting up a practical investigation, it would be quite usual to start with a demonstration of the experimental setup, showing, for example, how the equipment is arranged and how measurements will be taken. This would be a time when most science teachers would use question and answer to check their students' understanding. My own experience as a laboratory teacher is that if I rely on thinking up these questions off the top of my head whilst talking students through the experimental setup, most of the questions I come up with will be of the lower order kind, questions that can be answered with a single word or number or short phrase. In order to have students thinking more deeply, considering their answer before offering it, even perhaps giving a partial answer which is then fleshed out by contributions from one or more other students, I have to be asking more challenging, higher order questions. I can guarantee this will happen if, in my lesson plan, I write down the text of questions I will ask at particular points in the lesson, even perhaps pencil in alongside the name of specific students to whom I will pose those questions. If I'm doing this while setting up a core practical, then it's good to know that within the core practical guide, each core practical comes with a list of questions to enhance learning, and these include a good proportion of higher order questions which are ideal for this purpose. The more you use them, the easier you'll find it coming up with your own. The core practical guide can be freely downloaded from the subject website. One way of getting students to engage with the command words is this. Pairs of students can be given a command word to use, or they can be given free choice, most likely from a reduced list. You might also provide content material to base the question on, such as, for example, the graph shown here. And pairs then design a question, possibly preceded by a class discussion about the success criteria of a good question. For example, it contains only one command word, must be answerable from the data provided. Pairs then form into groups of 4 to peer assess and ensure that each pair has a solid question. Students are then asked to move around the class, finding 3 other questions and answering them. Using this strategy, students can answer a whole range of questions based on the same data within one lesson. There's a lot of opportunity for learning by students talking to one another about how the command words apply in different situations. One command word which students find especially challenging, according to examiner reports, is this one, devise. It's new to this specification and is used when students are asked to plan a new experimental investigation using their knowledge, most commonly using methods and techniques learned during one or more of the core practicals. So, students are using methods and techniques which they're familiar with, but applying them in an unfamiliar context to investigate something slightly different from what they were investigating in the original core practical. You'll remember that this switch of context often throws students and they find these questions challenging. We can build their confidence in tackling these questions by providing opportunities during the course for students to devise and, if possible, to carry out follow-up investigations which do exactly this. Use techniques recently learned to investigate something different. It might mean something as simple as changing the variable which has been looked at. If there are several possible alternative follow-up investigations, it can be a very powerful learning opportunity to have different groups of students devising and carrying out different ones, and then sharing their findings with the rest of the group afterwards. The more students talk about what they've learned in science, the more likely they are to be able to express those ideas clearly and logically, using the scientific terminology correctly, in writing later on.